Hello, everyone. My name is UNAVCO from Alaska, working with Jeff Remuller. Sorry for my foreign accent. Presenting our work on the vertical deformation in the Nepal Himalaya constrained by GPS and the GRACE measurement. So first, I will talk about the correlation of seasonal variation between GPS and the GRACE. Then we'll discuss the long-term vertical deformation in this area and try to provide some insight into how to separate tectonic and non-tectonic deformation. So why we study this area? Because we have a strong collision between India and Eurasia. We also have a significant mass loss due to the climate change. And Caltech has installed more than 30 continuous GPS stations in this area. All the GPS stations shows very strong seasonal variation and also a long-term trend, which mainly due to tectonics. And the GRACE observation also indicates a significant seasonal variation and also a long-term mass loss due to the melting of ice and snow on the high mountains of Himalaya. And how we correlated GPS and GRACE. So we can use GRACE observe the mass change, and the model is resulting loading deformation, and compare it with GPS. And in our project, we use GRACE derived spherical harmonic coefficients and also load level numbers to calculate the vertical displacement due to the changing load. And if we see the GRACE divided vertical deformation, and it's still a strong seasonal variation and also a long-term uplift due to the mass loss, because the Earth behaves very elastic body. If you have a decrease of mass, it will uplift. And if we compare GPS observation and the GRACE modeled vertical displacement, they show very, very good correlation. So if I plot the stacked seasonal displacement, the agreement between GPS and the GRACE seasonal variation is very nice. It's striking for me. And first, we use WRMS reduction to evaluate how well GPS and GRACE correlate to each other. And it turns out the average WRMS reduction is about 45%. And I also compared the annual amplitude of GPS time series and the GRACE time series, and it turns out that the agreement is still very good. So because we have a very nice correlation of seasonal variation, we think the GRACE modeled vertical uplift due to the mass decrease is still true and is mixed in the GPS measurement. So this figure shows the uplift GRACE predict uplift due to the mass decrease. And we can remove this uplift from GPS observed vertical rates. And the residues we think are mainly due to tectonics. And after this correction, we can see clearly the uplift of heading wall and the subsidence of footwall. And I also compared the corrected vertical rates with some interseismic model. It turns out most of the vertical rates can be interpreted by the interseismic strain of the MHT. In the horizontal direction, so because the loading we are talking about here is mainly due to hydrology, monsoon in Nepal and India. So for the horizontal movement is mainly in the north and the east direction. Another interesting thing to see is if we have a campaign GPS station measured at a different time of year, the fit line will be biased by seasonal effect. If we correct with GRACE data, all the measurement will be in a straight line. And summary, we see strong correlation between GPS and GRACE in Nepal Himalaya, and we also try to provide some insights into how to separate GPS and GRACE. And I'm a student. I'm hoping to finish up later this year. I'm looking for a postdoc position somewhere. If anybody interested in my work and me, I'm happy to talk. Thank you.